Hello everybody, my name is Ana Maria Lopez and this is the lesson 3 included in the course related to the policies in the electricity and heat supply sector. During this presentation, we are going to review relevant content related to the emission trading schemes. To this end, we need to understand some aspect of the carbon market, which is that we are going to do in the first section of the presentation. After that, we will revise the European Union emission trading scheme and we will use it as example to study main concepts. During section 3 and 4, prices and learned lessons obtained from the first period of the European Union emission trading scheme will be addressed. So, we are going to start with the overview of the topic. Today, one of the main ideas to understand is what is a cap. A cap sets a maximum acceptable level of pollution and it penalizes companies that exceed their emissions allowance. Actually, no other system can guarantee so lower emissions. The cap is a limit on the amount of pollution that can be released, measured in billions of tons of carbon dioxide or CO2 equivalent per year. It is established by the government authority, but is based on science data. To continue, I want to say that emitters can release only limited pollution. Allowances, in this case, are distributed to polluting entities, 1 allowance per ton of carbon dioxide or CO2 equivalent heat-trapping gases. The total amount of allowances will be equal to the cap value. One relevant aspect is that this value declines. The amount of greenhouse gas emissions permitted declines each year, creating demand. Then, the market price of carbon emission rises. So, there is an incentive for businesses to invest in technologies that are more pollution efficient, including the carbon sequestration. This is clear. When offered enough money or faced with high enough costs, polluters who own allowances or need allowances will reduce their emissions. So, these trades establish a market price for allowances. Carbon market could represent an excellent source for investment in environmentally sustainable development in developing countries. Linking the carbon market between countries, several potential benefits can be achieved, including reducing the cost of cutting emissions, increasing market liquidity, making the carbon price more stable, leveling the international playing field, and supporting global cooperation on climate change. But how can we visualize a simple example to understand the carbon market? In this slide, I have the chance to explain how it works. We can suppose that 2 plants are operating. So, we need to pay attention on the historical emission of the plant, available allowances, and the current emissions. For these values, it is possible to determine if each plant can sell or buy. Go to start analyzing plant A. As we can observe, the historical emission of this plant is fixed in 1,000 tons of CO2, and this plant has an available allowances of 900 tons. However, this plant has an important feature. Its current emission is 800 tons of CO2. What does this data mean? It is easy. Pay attention again on the current emission and the available allowances. It is evident that this plant is not emitting its available allowances. This plant can sell 100 tons of CO2. Now we can work on plant B. Basically, it's the same analysis, but we need to observe that the current emission in this case. In this case, it is evident that plant B is exceeding 100 tons of CO2. This value is easy to determine if we say current emissions minus available allowances. So, both plants are in different situations. Plant A could sell 100 tons and plant B should buy 100 tons. So, after analyzing first concept, the question why a carbon market needs answer. And we can start saying cost effectiveness. As shown in this slide, the most important point is that emissions of pollutants can be reduced independently of the geographic situation. The global warming effect to the society and the reduction generate benefits for all. So, the idea is to advance toward the neutral scenario. This means we need to create a global balance of zero emissions considering the human activities. Related to the last point, flexibility is one of the key elements of the carbon market, since emissions can be reduced in different geographic locations at different times and through different sources. Then, the cap provides certainty about environmental outcomes. After the first approach to the carbon market, we are going to continue with the emission trading scheme, considering Europe as an example. To manage industrial greenhouse gas emissions is created the emission trading schemes. This is a powerful policy instrument focused on reducing emission of man-made greenhouse gases. These gases are largely responsible for warming the planet and causing climate change. Therefore, this is a government initiative to address climate change. Regardless of the region that promotes, is defined as a government initiative. Trading responds to the main objective of the climate change policy of efficiently directing capital within markets toward low to zero carbon emission investments. To achieve this aim, an emission market requires some properties. First, scarcity of emissions allowances in order to create the price signal for businesses and governments alike. Second, a long-term clarity and predictability of rules, target, and the regulatory system guiding emission market worldwide. Third, adequate compliance periods allowing companies to structure a make-or-buy approach to their emission reductions over time. And finally, cost containment provisions allowing efficiency in discovering of lowest cost solution, whatever they are to be found. So, ensuring that carbon has The proper links in all of these markets will require some instruments or mechanisms, as for example, harmonized benchmarks, ambitions, rules, monitoring and enforcement within an array of approaches, structures and regulations to link different approaches and systems directly or by exchange rates of market instruments, or even worldwide offset mechanisms based on supportable emission reduction projects and programs. The offset-based mechanisms offer the opportunity for countries or sectors that have yet to introduce an allowances-based approach to participate in the market. Actually, there is not a worldwide instrument. Currently, different regions work on their emission trading schemes mechanisms. In this slide, we observe the main regions that have the instrument running out: the European Union, New Zealand, Australia, and United States. In spite of the fact the theoretical and methodological aspect could be raised from any of them, we go to work in this class using the European Union emission trading scheme. As will be mentioned along the season, in the world, it is the world's largest greenhouse gas emission trading system, and then a good example to explore it. It was in the United States where the emission trading schemes started to gain popularity. This fact was 7 years before Kyoto Protocol, but focused on traditional pollutants related to acid rain. Nitrogen and sulphur oxides were the pollutants selected as reference, but Europe is the first region who starts a mandatory CO2 cap and trade scheme. It is known as the European Union emission trading schemes. The instrument began to operate in 2005 during 2 years. This is known as the first phase and was ended in 2007. Currently, the experience obtained under this period was generated a large number of learning sessions, which will be commented later. The second phase is also ended, and the last year it began to operate the phase 3, which is planned to finalize in 2020. So, considering all these aspects, Europe is now known as a pioneer in this instrument. However, outside Europe, greenhouse gas schemes are under development. The United States and Canada are working on these initiatives. Also, China and India are examples from emerging economies involving in this issue. In particular, they support market-based instruments like emission trading schemes, and they are in favor of relative rather than absolute targets that are linked to economic growth. This type of scheme is known as performance-based cap and trade. In any case, there are an increased number of countries, regions, cities, and states placing emission policies to limit trading CO2 emissions. Many of them turn to the experience of the European Union emission trading scheme, which is the largest greenhouse gas emission trading system in operation. This slide lets us to visualize the situation in different regions. We can observe that Europe and Australia are the main regions where emission trading schemes has advanced. However, The trial period between 25-27 of the European Union emission trading schemes is a novel mark of cut and trade programs, and it is one that commends itself for a global system. One important characteristic that this trial period shows was that countries required time to be prepared and work in an effective way. This is found observing the data deficiencies in Eastern Europe, where they were greater than those observed for the other European countries. Moreover, most of the East European governments required more time to set up the requisite infrastructure for trading and enforcement. However, one of the most encouraging aspects of the trial period has been the evidence that participants and governments in countries with less institutional capacity can acquire the requisite infrastructure and become full-grown participants in a few years. This trial period started in January 2025 as the largest multi-country, multi-sector greenhouse gas trading system worldwide. The trial period was even more important for the new East European member states, when the institutional preparation was maybe not as complete as among other countries. This has been rightly raised as an important issue, considering the feasibility of a global trading system. But this trial period cannot be considered as the beginning of the process. It is important to remember previous steps and significant data. Between 1990 to 1997, there was an skeptical view of the emission trading in Europe, although finally in 1998, the first discussion by the Commission took place. 2 years after that, it was published the Green Paper on Emission Trading, and in 2001, the first Emission Trading Directive was proposed and adopted in 2003. Finally, just 2 years after, the European Union Emission Trading Scheme was launched. Remembering phases, the second phase of the emission trading scheme is built on the experience gained from the preliminary phase 1. The European Commission believes that the phase 1 learning by doing exercise prepared the community for the difficulty to achieving the reduction requirements of the Kyoto Protocol. Several positive results from the phase 1 experience assisted the emission trading schemes in making the phase 2 process run smoothly, at least for so far. First, phase 1 establishes much of the critical infrastructure necessary for a functional emission market, including emission monitoring, registries, and inventories. Most of the published difficulties in the emission trading schemes experienced early in the first phase can be traced to inadequate emission data infrastructure. Phase 1 significantly improved those critical elements in preparation for Phase 2 implementation. Now, the European Union is committing to achieving a 20% reduction in greenhouse gas emissions by 2020 from 1990 levels, or more depending on the action of the other countries. A strategic component of the effort to achieve this target is a revised emission trading scheme that will achieve a 21% reduction from covered entities from 2005 levels. Considering the relevance of these phases, we go to check main points in every period. The phase 1, carried out from 2005 to 2007, is characterized by being a pilot phase, adopting national action plans where CAP per member state were estimated. Also, in 2005, more than 300 million European allowances units were traded with a value close to $8 billion. And finally, allocating greatly exceeded demand, and in 2007, the price of the European allowances unit fell to zero values. The phase 2 took place from 2008 to 2012. This phase coincided with the commitment and the Kyoto Protocol over the same period. Moreover, at least 90% of the European allowance units were allocated for free. In March 2010, took place the sale of user-certified emission reductions, also called CER, by Hungary outside of the European emission trading scheme. The user-CER re-entered to European Union emission trading schemes and led to partial suspension of trading. In January 2011, there was a thief of over 2 million of European allowances units, led to suspension of trading in national registries. Additionally, in the same year, there was an 18% of increment in volume of carbon trade from 2010. And finally, the aviation allowances were introduced in 2012. And it is the phase 3 from 2013 to 2020. This is a single Europe-wide cap with centralized registry. In 2020, it's expected that emissions will be down at least 21% from 2005 levels. Moreover, more than 40% of European allowance units were issued in 2013 to be auctioned, and this percentage is expected to be increased year per year. This phase covers 45% of the total emission from the European countries. Although aviation was included, transport, domestic emissions, or those from agriculture were still outside the scope. It is an output for small emitters and hospitals in the United Kingdom. But how European Union emission trading system works? What main concepts are involved? To start, we need to introduce the cap and trade scheme. If we observe the picture on the left side, a cap or limit is set on the total volume of emission allowed by the installation in a specific region. This value is a finite number of emissions allowances which are available and reflect the cap. To define this cap, Europe defined the National Allocation Plans, or NAPs, which are based on scientific studies. Basically, two ways are issued: grandfathering and benchmarking approach. Both have been used into the European Union emission trading scheme during different periods. But what grandfathering is? Well, grandfathering is a well-known method because it was the method used to create NAPs during the first and second trading periods, from 2005 until 2012. The method is classified as a static method based on the historical emission generated by a specific undertaking. However, although initial allocation of emissions allowances were predominantly performed by means of grandfathering, during the first phases of the emission trading scheme, European member states were already permitted to auction small numbers of allowances. Regarding benchmarking, it uses an amount per unit of production. Benchmarking is an approach to assess performance based on objective and transparent criteria and indicators. On the one hand, the design of benchmarks and benchmarking strongly depends on the specific purpose. For example, voluntary approaches, regulatory approaches, emission trading schemes. Actually, not all existing benchmarking approaches are suitable for the needs of an emission trading scheme, and not all benchmarking approaches are suitable for all targets. On the other hand, target functions of benchmarking within the European Union emission trading schemes consider compensations, rewarding early action, and preventing operational and/or investment leakage from 2013 onwards. In spite of the fact that grandfathering was used during period 1 and 2, economists advocate benchmarking over grandfathering as the preferable method of determining NAP's cap in long term. Free allocation of allowances is one of the used methods. At the beginning of each year, the European Union allocates to each member state the number of emission allowances equal to the cap set up in their NAP. During the first trading period, member states were required to issue 95% of their allowances for free. In the second trading period, the requirement of free allocation was dropped to 90%. During the last period, this method was changed to emission allowances actioning, which is defined from physical action conducted by member states, whereby industries included in the European emission trading scheme have the opportunity to buy emission allowances at the current market price. Now we go to pay attention on auctioning method. This is the actual method and most transparent. In Europe, there are two platforms that are controlling it. The first is the European Energy Exchange, located in Leipzig, which is used for the large majority of countries in the European emission trading scheme. The European Energy Exchange has established itself as the leading auction platform for emission allowances in the European emission trading scheme. The European Energy Exchange has been awarded the role as the transitional common action platform to auction allowances on behalf of 24 member states. In this capacity, the European Energy Exchange also conducts emission auctions for Poland during a transitional period. In addition, the European Energy Exchange has been selected as Germany's permanent auction platform. Second one is the ESE Future Europe, located in London, which is the second one but is acting as the United Kingdom platform. One important characteristic is that the total emissions are reduced on a year-by-year or phase-by-phase, typically increasing the stringency of the scheme gradually. As an example, the 2013 cap for emission from power stations and other fixed installations in the 28 European member states and the 3 EEA EFTA states, which are Iceland, Liechtenstein, and Norway, was set at 2 billion allowances. During phase 3 of the European emission trading scheme, this cap decreases every year around 2% of the average total quantity of allowances issued annually. In absolute terms, this means the number of general allowances will be reduced annually by more or less 38 million. Thanks to the decreasing cap, in 2020, emissions from fixed installation will be 21% lower than in 2005. Even the annual reduction in the cap will continue beyond 2030 to achieve the target of a 40% reduction in European greenhouse gases emission below 1990 levels by 2030. The cap will need to be reduced a higher ratio than now to achieve this objective. At this point, we can invest some minutes to understand the emission trading scheme using a visual example. To access to it, please use the link provided in the slide and use the video and see the video before to going on to the presentation. Continue with the presentation. We can say that large power stations and other combustion plants, oil refineries, coke ovens, iron and steel plants, and factories making cement, glass, lime, bricks, ceramic, pulp, paper, and board are covered from the beginning in the emission trading scheme. From 2013, the scope of the emission trading scheme was extended to also include other sectors and greenhouse gases. CO2 emissions from petrochemicals, ammonia, and aluminum were included. Also was the dinitrogen oxide emission from the production of nitric, adipic, and glycolic acid production and perfluorocarbons from the aluminum sector. The capture, transport, and geological storage of all greenhouse gases emissions were also covered. These sectors receive allowances free of charge according to the European-wide rules, in the same way as other industrial sectors already covered. In 2012, also, the aviation was included in the European emission trading scheme. European emission trading scheme has important challenges. Carbon leakage is generally defined in terms of differentiated carbon policies, and the resulting impact on greenhouse gas emissions and the phenomenon is much more complicated, involving differences in countries' economies and trade flows among them. In the context of analyzing the effect of differentiated carbon policies, carbon leakage is a twofold problem. The first is the possibility that introduction of a carbon control regime in a country ahead of the introduction of a comparable policy in competing countries could result in the production of greenhouse gas intensive products diminishing in the country attempting to control emission and increasing in competing countries with no carbon controls. Basically, countries with carbon control risk losing global market share to competing countries without controls. This will counteract the net reduction achieved by the country attempting to address climate change and reward economically the countries that were not. The second problem is a long-term possibility that future investment by greenhouse gas intensive industry could be channeled to countries with no or less stringent carbon controls, circumventing carbon reduction needs and potentially looking in obsolete technologies. This reallocation and construction of new facilities without carbon control could make future reduction more difficult and expensive. Another situation is the competitiveness effect. The classical example is the China syndrome, which is translated as the unfair advantage for industries in developing countries. Leadership is another question. The European emission trading scheme involves many interests around the world. One example is the aviation sector. This sector was recently included, but is it a competition concern or environmental concern? It is clear that the role of the European leadership needs to be addressed, but this is part of the theme. Continue with the presentation index. The next topic is about prices. Now, a carbon price exists, established by the European Emission Trading Scheme. In the first phase, it has been volatile, as we can observe in the picture, because information about Europe's industrial emission data quality exactly was poor. So the market got a shock in early 2006 when it emerged that the European Commission had been too generous with the allowances it handed out to industry. The fall of the allowance price in 2007 has been attributed both to a glut of allowances and to the impending economic slowdown preceding the world financial crisis of the coming years. Of course, with allowances having no penalty value, emission sources were free to continue business as usual, rather than to curtail them. On the other hand, when allowances has a significant price, businesses were able to pass along corresponding price increases to customers, which resulted in windfall profits. The current situation is that the emission trading scheme price for emission allowances has fallen drastically in the last 5 years, as demand for energy has fallen because of the recessionary conditions among European countries. This has led to an oversupply of unused allowances. The emission trading scheme is reevaluating its allocation of allowances in an attempt to rebalance the trading system and maintain a price on emissions. Finally, we are going to revise what are the most relevant lessons learned obtaining from the first period of the European emission trading scheme. The first lesson advised about the necessity of high-quality emission data to set environmental goals. From the first period, European Union worked on limited data available. It is evident that the second phase takes advantages from the first one to define caps. However, new sectors have been included and the situation is similar. Therefore, European Union needs to design complementary policies to improve this barrier. Lesson 2 is about the importance of the consistency and predictability. Industrial sectors have a role to play in achieving the 2020 and 2030 climate and energy target. They hold potential to contribute to research and innovation and technology developments that will be help toward a low-carbon economy. This implies significant investment that require a predictable and consistent legislative framework. With regard to carbon leakage, consistency is the methodology essential when assessing vulnerable sectors. So far, the years 2030 and 2040 with carbon leakage status have proved to safeguard what's a progress in innovation, technology developments, and by that reaching higher efficiencies, more renewable energy inputs, and lower emissions. Regarding Lesson 3, we need to mention some indicators. Inclusive of largest emitters and sufficient sources for trading, but large number of small installations included, since 36% of the total installations are responsible for around 1% of emissions, and even 7.5% of the total installations are responsible for 60% of emissions. Additionally, the third phase of emission trading scheme allows a small installation lower than 25 megawatts and emitting lower than 10,000 tons to opt out. On the other hand, Lesson 4, which is focused on the need to have flexibility and provide long-term certainty, is addressed in Phase 3, since trading is extended to 2020. Moreover, banking was allowed between Phase 2 and Phase 3 to avoid previous bad experiences. Finally, Lesson 5 and 6 demand efficiency and transparency. In this slide, main points are highlighted, but additional infrastructure for transfer, monitoring protocols, clear all third-party verifiers are required. Registry systems to track allowances and annual reporting are required.